What's the point of streaming? Hey, what's up? It's Mark at alchemist.camp, where we learn Elixir and Phoenix by building things. Today, we're going to look at streams and why you might use streams as opposed to the enum functions. You may notice the stream functions are very similar to the ones available in enum, and streams are in fact enumerable, but there are some reasons. So we have here a bunch of to-dos. I've started up IEX and we'll paste those to-dos in. Let's say we want to format these to-dos. We might want to use enum.map and actually probably enum.withIndex first, just to get indexes like so. And then we'll enum.map over this list of to-dos, and each one, let's see, is going to be a string with, we'll have to define it this way since we have the index. So we have to-do and an index, and that will return a string with, say, the number of the task, so task number, and then whatever the index is, and then whatever the to-do was, and finally a new line. And end that, and then maybe we put them all into a string, just combine them, so enum.into a single string, and then io.puts, and there we go. Task 0, check Twitter. Task 1, make some silence. So this is all like very SF 2014 kinds of tasks. And then you might say, well, this is good enough. And it probably is. It depends on your use case. If you have a lot of items, though, this can be expensive because this enum with index will iterate over the entire list, and then the enum.map will iterate over the list again, and then the enum.into will iterate it over it again. What streams do is they give you a lazy way to do the same thing. So if instead of enum.map, we just said to-dos and then stream, instead of enum.withIndex, we could do stream with index. It's the same function name, does basically the same thing, except this is not doing the calculation. It's just creating a function that will do the calculation. And say we want to go another step, we'll do stream with index and then stream.map, and we'll do all of this in one line just since it'll make it easier working through IEX. So we have our to-do and our index again, as we did before, and we have a string task number I and to-do and a new line, and then we end like so. So at this point, we have two functions here. None of them have been executed. So there is some overhead setting up the stream, but as you can see, it's very lightweight until we actually decide to do the calculations. And then finally, what do we have? We had an enum.into. We're going to use enum.into now because we want to actually convert it into a string. And now we have the same result that we had before, and it may or may not be more performant. In order to test that, I have made a set of quick timer utilities. So I just made a stopwatch function in the module here, and I made a function to calculate the time that the enum takes. It's got a repeat, so I'm going to do the calculation 5,000 times because it's just so fast otherwise that it's pretty difficult to compare. So these two functions do exactly what I just walked through in the shell. Let's have a look at how the timing works. Now, as I said, this is going to do it 5,000 times. So y stream time to do enum, and we can see it's about 3 seconds. And if we do to do stream, it's about 2.5 seconds. Now your mileage may vary. It could very well be you'll find the enum is faster, and that's because there is some overhead in setting up the stream. However, if you have a case where you're not even working with all of the data, such as this example I've made, I have a calculation enum, and this is taking all the numbers from 1 to 1,000,000, filtering to just the multiples of 3 that aren't multiples of 5, squaring all the numbers, and then taking just the even numbers, and then just taking 15. In this case, we're running the enum at each of these steps on, thank you VS Code, on all of the elements. In this case, the calculation stream, since it's lazy, we're just getting the first 15 elements. Now there's some things here where we do have to run through the calculation on everything, but you'll see the overall cost is much, much lower. ystream.time calculation enum first, and that took us 197 milliseconds, and with the stream it took us 3 milliseconds. Obviously, one of the main times you'll want to do this is when you're working with a file. So just like there's an enum equivalent of most there's a stream equivalent of most enum functions, there is a stream equivalent of file.read. So file.read will return the entire contents of the file. So say in the lib directory, we'll just get the contents of this rational file. It's for rational numbers. So we do tips/rational.ex, and no such file or directory. Oh, because we're already in tips, it should be lib/rational.yes. Okay, so we got all of that. And then if we want to work through the individual lines and do something, we'd have to use enum.map, and actually we'd probably do string.split on new lines. And then after that, we could do an enum.map, say using the filter that I wrote in this file already. It starts with a def, so this will just get the lines that start with white space and then the characters def. So we'll do enum.filter ystream.starts with def, and this has got to be /1 because this is a named function. We've got to capture it. Okay, so say we do that, and then enum.map, and we just print them all out. So io.puts. Okay, and now we just get the lines that start with def, including the def module and the def struct. And we can replace file.read with file.stream with very similar semantics to what we had before. In this case, we get back a stream struct, and it does break everything into lines for us by default, which actually makes it a bit simpler for us. We don't need the stream.split anymore. And just like we did the enum.filter before, we can do a stream.filter and filter on that filter function that we wrote, ystream.starts with def. And this still will not execute anything. It's just building up the functions that will be used to transform it. Then finally, we can do an enum.each and io.puts, and there we go. We get just the definitions and the def module and whatever starts with def. So as you can see, this is a clear win if you've got a gigantic file, like you may not even be able to fit it all into memory. And here we can just go line by line and then work with just the filtered portion of it that we want to. So to summarize, streams are lazy, so sometimes they can avoid doing work that you would have had to do with enums. There is some overhead though, so they're not always more performant. And when you're working with streams, it feels like working with enums for the most part, or it feels like working with the enum module for the most part. You have most of the same functions. The only difference is at the very end, you've got to have an enum or something in it to convert from a stream into the actual executed result of those functions. Hope you found this useful, and I'll see you next time.